Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about present value of ordinary general annuities. Just a quick recap of what an ordinary general annuity is. Any annuity is equal payments at regular intervals. An ordinary annuity is payment at the end of the interval, so the end of the month or the quarter or the year or the week. And general means that the frequency of the payments is not equivalent to the frequency of the compound periods. So we're going to take a look at an ordinary general annuity and how we find present value. Where you might see this is a question like this. It says a 30-year mortgage requires payments of $1,300 at the end of each month. The interest rate is 7% compounded semi-annually. And you're asked, what was the present value or the mortgage principal? We know that this is an ordinary general annuity because it's at the end of the month and it's compounded semi-annually, so twice a year, and payments are made monthly, so that's 12 times a year. First of all, we'll put all our information in a timeline. We want to know present value, we know the interest rate, we know the payments, we know the time. In order to solve this, we're going to use a formula first, and then I'm going to show you how to do it on this calculator. Therefore, if you're not interested in the formula, you can just skip ahead and look at how you do it on the calculator. But if you do need to know how to do it manually with a formula, then you can take a look at this. The formula that we're going to use is this. It looks pretty intimidating, but it's similar to the formula we used for finding future value with ordinary general annuities. These letters represent exactly the same things. So PV, which is the present value, will equal PMT, which is the payment amount, times, in the numerator we have 1 minus, square bracket and then small bracket, 1 plus I, where I represents the interest rate per compound period, to the exponent of CY over PY. So CY represents a number of compound periods per year, PY represents the number of payments per year. All of this raised to the exponent negative n, where n represents the total number of payments. In the denominator, we have 1 plus I to the power of CY divided by PY minus 1. Let's find what these values are in the context of this problem and solve it. So our payment amount is $1,300. The interest rate, it's 7% compounded semi-annually, so twice a year. So we take 7% divide by 2, so it would be 0.035 per compound period. The number of payments, there are 12 per year, over 30 years would be 360. Compounded semi-annually, so there are 2 compound periods in a year. Paid monthly, so there are 12 payments per year. Let's plug these into our formula. So we'll have present value equal to $1,300 times 1 minus 1 plus I, so 1 plus 0.035, to the exponent CY over PY, which will be 2 over 12, then to the exponent of negative n, which is 360. In the denominator, we'll have 1 plus I to the power of 2 over 12 minus 1. If you want, you could simplify this before throwing all of this into your calculator. It depends on how comfortable you are using the brackets and the order of operations. So first of all, we can add 1 plus 0.035, and then we can reduce 2 over 12 to 1/6, and then we can use our law of exponents that allows us to take this power and raise it to this exponent and simplify it. The way we do that is we simply multiply the exponents. So 1.035 to the power of 1/6 to the power of negative 360 will be 1.035 to the power of 1/6 times negative 360, which is just negative 60. That might be a little bit easier to handle when you're putting it into your calculator, but you also could have put it in without simplifying first. Either way, you should get a present value of $197,387.41. Now let's take a look at how much easier this calculation can be using our business analyst calculator. To start with, we're going to fill all these values out and then we'll enter them into our calculator. So the payments per year, if we're making payments each month, will be 12. If it's compounded semi-annually, there are 2 compound periods per year. N is the total number of payments, so there's 12 per year times 30 years, which would be 360. The interest rate is 7%. We're finding present value, the mortgage principal, so that's what we're finding. The payment amount is $1,300 and we make that negative. and the future value once the mortgage has been paid off will be 0. Before we start, let's clear any previous work. So second function FV, and let's enter P per Y and C per Y. So second function I per Y gives us P per Y. It's already 12, we don't need to change it. To get C per Y, we scroll, and it's 2. If we didn't have these numbers, we would simply put the number in, so in this case 2, and then go enter. And it will replace what was in there before. Once we've got those values what we want, we get out of there by quitting, so that's second function quit. And now we enter all of these values. So we put the number 360 and then N. I per Y is 7, so 7 I per Y. We don't know PV, that's what we're going to find, so we'll come back to that. Payment is negative 1,300. 1,300, it's negative because you're making that payment, it's coming out of your pocket, so that's our payment. Because we've already cleared everything, future value is going to be 0, we don't need to enter anything. And now we want to calculate present value, so compute present value. And we get $197,387.41, which is the same value we got when we used the formula. However, this was much quicker and easier. So whether you use the formula or the calculator is going to depend on what's required. But if you have a choice, the calculator is going to be your best bet.